Hello and welcome back to JD Science Prep. Today we are discussing kinematic equations. This is going to be part 2 of this mini series I have going on. So the examples today are a little bit more advanced. If you are interested in that, please stick around. If you need a little bit of a brush up or a review, please refer to the first video in this series. But before we begin, just quickly here, if you need to pause the video and take a look at our equations that we're working with today, please do that. And let's get to work. So number 1, it says a vehicle starts from rest and accelerates for 7.45 seconds over a distance of 128 meters. What is the vehicle's acceleration? So again, let's discuss what we have from the question. So it looks like we have the time, we also have the distance, and if you remember from last video, if we see a vehicle or an object starting from rest, we also have the initial velocity. So our VI, because it's at rest, will just be 0 meters per second. We have the time, and that's going to be 7.45 seconds, and we also have the distance, which is going to be 128 meters. And we are looking for the acceleration in this question. So let's scroll on up here. Let's take a look at what formula we should be using here. So it looks like we have the distance, we have the VI, and we also have the t, and we're looking for the acceleration. So there's no formula that strictly solves for acceleration here out of these 4, which means we're going to have to manipulate one of them. And the one that we are going to use is this one near the bottom, because we have all the variables except for acceleration, so that one should work quite well. So the first step, or the first thing I prefer to do, is manipulate my formula. Then we can insert our numbers. So let's go ahead and do that. So our formula again is just going to be our distance equals VIT plus 1/2 AT squared. So we have to get acceleration alone. So the very first thing I am going to do is I'm going to get this 1/2 from the right side to the left, which means I will multiply that by 2. I'll multiply the left side and the right side by 2. So what we now have is our distance multiplied by 2 equals VIT plus AT squared. So the next thing I'm going to do is I'm going to subtract my VIT from the right side as well as from my left side, which will then eliminate that. So we'll have D multiplied by 2 subtract VIT, and that's going to equal AT squared, which leaves us with one step left. Let's get that T squared over to our left side, which gives us our final formula of our distance multiplied by 2 subtract VIT, and that is all going to be divided by T squared, which will give us our acceleration. So that looks good to me. Let's go ahead and plug in some numbers for ourselves. So we have our distance, which is 128 meters. That's going to be multiplied by 2, subtract our VIT, which is just going to be 0, multiplied by 7.45. So again, if you remember back from our last video, anything multiplied by 0 is 0. So this pretty much cancels itself out. And that's all going to be over 7.45 squared, and I'll just put the units there just in case. And that is going to equal our acceleration. So when you type that all into your calculator, you should get an answer of 4.61 meters per second squared. And just quickly looking at our significant figures, we have 3 in 7.45, 3 in 128. So this looks pretty good to me. So again, our acceleration will be 4.61 meters per second squared. Always remember to include those units. Moving on to number 2 here. Let's scroll on down. So it says, a vehicle is traveling at 24 meters per second and comes to a stop in 3.1 seconds. What is the distance the vehicle took to stop? So again, let's write out what we know. So we know the vehicle is traveling at 24 meters per second and it comes to a stop. There's a key word and it is in 3.1 seconds. So it looks like our initial velocity is going to be 24 meters per second. And as it comes to a stop, that's going to be our final velocity. So it's just 0 meters per second. And we also know the time, which is 3.1 seconds. Okay, so let's take a look up at our different formulas here and let's see what we can use. What makes sense? So again, we are going to be looking for the distance here, and I think this formula makes quite a bit of sense. We have d equals vi plus vf over 2. Multiplied by t, we have all of the required variables. So let's go ahead and write that formula down. So we have d equals vi plus vf over 2, and that's going to be multiplied by t. So let's fill in our numbers here. We have vi as in 24 meters per second plus our vf, which is just 0. That is all over 2, and that's being multiplied by 3.1. So let's write that in 3.1 seconds. All right, now if you want to pause the video and calculate that for yourselves, go ahead. If not, if you do type it into your calculator, you should find that you get a distance of 37.2 meters. Looking at significant figures here, we have 2 and 2, so I'm going to round this to 37 meters. So it took 37 meters for this vehicle to stop. Okay. All right, moving on to number 3. This one is a little bit of a trickier one here. Let's see if we can make some sense of it. So it says, if a person has a vertical leap of 1.01 meters, what is their takeoff speed and the time they are in the air? So we're looking for a couple different things here, and from the question, it really only looks like it gives us our distance, okay? But we can also assume a few different things here, and let's discuss what we're going to be assuming, okay? So we are looking for the takeoff speed, so that means we're going to be looking for the VI, okay? We also know the distance. That's kind of what it gave us. We have 1.01 meters. We also know the acceleration. So if you remember back from last video, the acceleration that gravity has on an object is going to be 9.81 meters per second. However, because this person is moving upwards, gravity is fighting against them, which means our acceleration has to be negative 9.81 meters per second squared, because the person is slowing down as they gain altitude. Okay, and also we can assume that our final velocity is going to be 0 meters per second, as the person will end up stopping. Okay. So we have a few different variables here. We had to make a few assumptions, but that's okay. Let's go ahead and figure out a formula to use because we are solving for VI initially. Let's scroll on up here. And what I think we should be using, I would pick this one right here because we have VF, we have A, and we also have distance. So we can manipulate and solve for VI. So let's go ahead and write down that formula there and we can get to work. So we have VF squared equals VI squared plus 2AD. And we can just manipulate this relatively quickly here. All we have to do is subtract 2AD from the right side as well as the left side, and that's going to give us VI squared equals VF squared subtract 2AD. So let's go ahead and input our numbers here. We have VI squared equals 0 squared, I guess that's in meters per second, subtract 2 multiplied by our acceleration, which is negative 9.81 meters per second squared. Remember to keep those negatives, folks. That will make a very major impact on your answer. And our distance is 1.01 meters. So if you type that into your calculator, remember, right now we're solving for VI squared. You should get 19.8. And all we have to do to get rid of that squared is take the square root of that. So if you take the square root of 19.8, you should get an answer of 4.45 meters per second. And sig figs look good. 1.01 has 3, so our answer should also have 3, so let's keep 3. Okay, so that's part 1. We have found the takeoff speed of this person. Now we need to find the time that they are in the air. Okay, so let's just draw a quick diagram here. This is going to be not a great drawing, but that's okay. So we have the ground, and this person jumps off the ground. And let's say this distance here is that 1.01 meters. So when we solve for time here, what we are actually going to be solving for is the time it takes this person to reach the peak of their jump. So the time it takes this person to reach 1.01 meters off of the ground. Okay, in order to find their total hang time, we need to multiply the time it takes to get to the peak by 2. If we do that, we will find the entire hang time that the person is in the air. Okay, so we're going to go ahead and do that. First, we need to figure out a formula to use. So let's scroll back on up to our formulas. And looking at the different variables that we have right now, I am going to go ahead and say we can use this first one and just manipulate for t. So let's go ahead and do that. Let's scroll on back down to our question here, and we are going to write out our formula. So we have VF equals VI plus AT. And again, let's just quickly manipulate here. So I'm going to subtract VI from the right side as well as the left side to have VF subtract VI equals AT. And finally, let's isolate for our time by dividing by acceleration on both sides. and that should give us time. So all we have to do now is input our numbers. So let's take a look here. We have VF is going to be 0 meters per second. Subtract VI, which is what we solved for. So 4.45 meters per second. And that's going to be over our acceleration, which is still negative 9.81 meters per second squared, because remember, we're still just solving for the time it takes this person to reach the peak height. Then we'll take that and divide by 2. So our acceleration should still be 9.81 or negative 9.81 meters per second squared. And that's going to equal our time. So if you do plug this into your calculator here, what you should find is that the time it takes this person to reach the peak of their jump, it should be 0.4536 seconds. And we're just going to take that and multiply it by 2. That's all we're going to do. So I'm going to keep all of those digits that I got. So 0.4536 seconds multiplied by 2, and what we should get is 0.907 seconds as their entire hang time. All right, folks. So that is the video. I had 3 examples for you. We went through them all. Hopefully it made a little bit of sense. And thank you for watching. If this did help, like and subscribe. Thank you very much.